Hi friends, welcome back to the series where we solve CAT DILR questions from CAT 2017. Please make sure you watch the first video from the series where we solve the first two problems from slot 1. We'll be taking a look at problems 3 and 4 from slot 1 in this particular video. So let's get started. So the third question is essentially, applicants for the doctoral programs of Ambi Institute of Engineering, that is AIIE, and Bamboo Institute of Engineering, that is BIE, have to appear for a common entrance test, that is CET. The test has 3 sections: physics, chemistry and maths. Among those appearing for CET, those at or above the 80th percentile in at least 2 sections and at or above the 90th percentile overall are selected for advanced entrance test, AET, conducted by AIIE. AET is used by AIIE for final selection. For the 200 candidates who are at or above the 90th percentile overall based on CET, the following are known about their performance in CET. So essentially this is only for those who are at or above 90th percentile, which is actually a subset of the overall set of people who are taking the exam. So let's see what is given about these guys. Firstly, no one is below the 80th percentile in all 3 sections. 150 are at or above the 80th percentile in exactly 2 sections. The number of candidates at or above the 80th percentile only in P is the same as the number of candidates at or above the 80th percentile only in C. The same is the number of candidates at or above the 80th percentile only in M. Fourth is number of candidates below 80th percentile in P to the number of candidates below 80th percentile in C to the number of candidates below 80th percentile in M is 4:2:1. BIE uses a different process for selection. If any candidate is appearing in the AET by AIIE, BIE considers their AET score for final selection provided the candidate is at or above the 80th percentile in P. Any other candidate or at or above the 80th percentile in P in CET but who is not eligible for AET is required to appear in a separate test to be conducted by BIE for being considered for the final selection. Together there are 400 candidates this year who are at or above 80th percentile. So there are 80th percentile in P. So there are 400 candidates who are at or above 80th percentile in P, and there are 200 candidates who are at or above 90th percentile overall. This all information relates to those who are at or above 90th percentile overall. And if you see the language, it's like pretty much only in P, only C. So this is like Venn diagram. So let's first draw the Venn diagram of people who are at or above 90th percentile overall. So we have the Venn diagram as this is a set of all people who are at or above 90th percentile overall. So there are 200 people in it, and this has been split according to the sets P, C, M. So let's draw them out. This is P, this is C, and this is M. And the first clue that we are given is no one is below 80th. So for them to be inside this set is that they are at or above 80th percentile in each of these particular subjects. If they are below 80th percentile, then they are outside the circle essentially. So if you are part of this circle, essentially you are at or above 80th percentile in physics. If you are part of this C circle, you are at or above 80th percentile in chemistry. And if you are part of the M circle, you are at or above 80th percentile in maths. If you are outside these 3 circles, you are below 80th percentile in all 3 subjects, but you are above 90th percentile overall. So firstly, let's see what that value is. No one is below 80th percentile in all 3 sections. So essentially out of these 3 circles, the outside value is 0. 150 are at or above 80th percentile in exactly 2 sections. So what is exactly 1, exactly 2, exactly 3? So this is say A, B, C, and this is D, E, F, and this is G. So basically they are saying that D plus E plus F is 150. Okay, and so we have placed these 2 informations already, so we can forget about them. Then let's see what this is. The number of candidates at or above 80th percentile only in P is the same as the number of candidates at or above 80th percentile only in C, and the number of candidates at or above 80th percentile only in M. So only in P is A, only in C is B, only in M is C. So essentially it's saying that A is equal to B is equal to C. but so we can directly just replace it. It would be easier dealing with fewer variables than with more variables as such. So we have eliminated some variables just by this particular line. So we have used this line as well. The last line is number of candidates below 80th percentile in P to the number of candidates below 80th percentile in C to the number of candidates below 80th percentile in M is 4:2:1. This is, have I used everything from this among those at our, so you have to be at or about 80th percentile in at least 2 sections and above 90th percentile overall to qualify for the AET as such. So the people who will be qualifying for AET are those who are at D, E, F, G essentially in this set. So those are the guys who are qualifying for AET. So we have used that information. Only the fourth point is remaining. Fourth point is that number of students below 80th percentile in P. So below 80th percentile in P is essentially this part, that is A plus F plus A. So that is 2A plus F. So 2A plus F to 2A, number of below 80th percentile in C. So below 80th percentile in C is 2A plus E. To below 80th percentile in M is 2A plus D. So this is 4:2:1. This is what we have been given. So this is the information that we have till now. So let's consider the fact that we have already removed almost everything as such. So we have 3A plus D plus E plus F plus G is 200. So 3A plus D plus E plus F plus G is 200. That is the sum of all the elements of the set. The number of elements outside the 3 circles is 0 as has been given by the first condition. D plus E plus F is 150. So 3A plus G will be 200 minus 150, that is 50. So this is the one condition we have. The second condition we have is that 2A plus F to 2A plus E to 2A plus D is 4:2:1. So let's assume that the ratio or the multiplier here is x. So that means 2A plus F is 4x, 2A plus E is 2x and 2A plus D is x. So we have all of this information. So if we add all of this together, we get 6A plus D plus E plus F is 7x. But this is equal to 150. So 6A plus 150 is 7x. We also have 3A plus G is equal to 50. So since these values cannot be negative, that means that G will have to be, the lowest value that G can take is when it's 0. When it's 0, 3A will not be a integer, it has to be a positive integer essentially. So G cannot be 0. So the min value G can take is G is equal to 2. And when G is equal to 2, 3A is equal to 48 and A is equal to 16. So the max value A can take is less than or equal to 16. Now we have been given that 6A plus 150 is 7x. So we have to find out values of A and x such that 6A plus 150 will be a multiple of 7. So let's start with these values where we have 6A plus this as 7x. So since it is above 150, let's consider all multiples of 7 which are above 150. If you see the LHS of this equation, the LHS is even. So all the multiples will essentially be even numbers. So x has to be an even number. So let's consider all the even multiples of 7. So the first multiple of 7 after 150, which is an even multiple, is 154. So when 7x is 154, A is equal to essentially 4. So 4 by 6. So this is not an integral value. The next even multiple is plus 14. So this is 168. So 6A is equal to 18. So A will be equal to 3. The next integral multiple is 172, 182. So when 7x is equal to 182, we have 3A is equal to 32. That is not a integer as such. So we can eliminate that. Add 14 more, we have 196. So this minus 150 is 46, not divisible by 6. So this is not an integer. Add 14, so this is 210. Minus 150, you get 60. So 6A is equal to 60 or A is equal to 10. Now we have add another 14, so we have 224 minus 150, so that is 74, not a multiple of 6. Then add another 14, that is 238, 238 minus 150, so that is 88, not a multiple of 6. So the next value, next even multiple of 7x will be 238 plus 14, that is 252. Minus 150, we get 102, divided by 6, we get 17. But the max value A can take is less than or equal to 16, so this cannot be. So we get essentially two possible values for A. A is equal to either 3 or A is equal to 10. So we have two essential, we have two possible values of A. Let's draw out the diagrams for that. So when A is either equal to 3 or A is equal to 10. And we'll have a corresponding Venn diagram for each of those two cases. So let's draw that out actually. This is the first question, but firstly I'll draw out both of the cases so that we can be clear about how each of those Venn diagrams will look. This is 200, this is 200. We have this is the case when A is equal to 3 and this is the case when A is equal to 10. So this will serve us for the remaining part as such. So when A is equal to 3, this value is 3, this value is 10. Let's solve first for A is equal to 3. Let's go back. So A is equal to 3, then we have 2A plus D is equal, if A is equal to 3, then 7x is equal to 168. So x is equal to divided by 7, so that is 24 as such. So x is equal to 24. So 2a plus d is equal to 24. So d is equal to 24 minus 2 into 3, that is 6. So d will be equal to 18 in this case. So in this case d is equal to so in this case d will be equal to 18. So this value is 18. Then we have 2a plus e is equal to 2x. 2x is essentially 24 into 2, that is 48. 48 minus 6 is 42. So e is equal to 42. Let's go to 42. Then we have 4x. So 4x is 96. 96 minus 6. So f is equal to 90. So this is the sum that we have. And 3a plus g is equal to 50. So 3a is 9. So this is g will essentially be 41. So this is the sum that we have. This is the Venn diagram we have in this case. When a is equal to 10, 3a plus g is equal to 50. So 30 plus g is equal to 50. So this is 20. Let's take a look at d, e and f in this case. So let's go back. 2a plus d is equal to x. In this case, x is equal to 7x is equal to 210. So x is equal to 30. So 20 plus d is equal to 30. So d will be equal to 10. So let me put that. This is equal to 10. Going back, 2a plus e is equal to 2x. So we get this value is 60 minus 2 into 10. So e is equal to 40. So this is 40. And last value is 2a plus f is equal to 4x. X is 30 in this case. So this is 120. 120 minus 2a, that is minus 20. So this is equal to 100. So f is equal to 100. So these are the two Venn diagrams that we get in this case. So let's see the questions according to these two Venn diagrams. What best can be concluded about the number of candidates sitting for the separate test for BIE who are at or above 90th percentile overall in CET? So who will have to sit for the separate test for BIE? Those who are above 90th percentile in CET. That is those guys who are above 80th percentile in P but were not qualified for the remaining exam. So all of these guys, that is those who qualified, this is PCM. So all the other guys qualified for the exam. So these 18, 41, 42 will not have to sit for the separate exam. And these guys 393 are not above 80th percentile in P, so they will not be eligible for BIE. So the only guys who will have to sit for the separate exam is these guys, only P. So the only P value is 3 or 10. So we can say that this value is either 3 or it is 10. So the answer to this question is 3 or 10. If the number of candidates who are at or above 90th percentile overall and also above 80th percentile in all 3 sections in CET is actually a multiple of 5, what is the number of candidates who are at or above 90th percentile overall and at or above 80th percentile in both P and M in CET? So they are saying that in all 3 sections is essentially the variable G. G is a multiple of 5. That means here G is 41, so this Venn diagram is not true, this Venn diagram is applicable. Here G is 20, which is a multiple of 5. So they are saying that this particular case is applicable. So in this particular case, we have to find what is the number of students who are at or above 90th percentile overall and at or above 80th percentile in both P and M in CET. So both P and M in CET is 40 plus 20, that is 60. So the number of people who are above 80th, at or above 80th percentile in both P and M in CET is 60. The answer is 60. Let's consider the third question. If the number of candidates who are at or above the 90th percentile overall and also at or above the 80th percentile in all 3 sections in CET is actually a multiple of 5, saying the second case is applicable, then how many candidates were shortlisted for AIIE for the AIIE by AIIE? So how many were shortlisted for AIIE will be the number who are like D plus E plus F plus G. So this particular case is applicable, and those who are shortlisted are 10 plus 20 plus 40 plus 100. So that is 10 plus 20 plus 40 plus 100. So this value is equal to 170. So 170 were shortlisted for the AIIE. So essentially who is shortlisted for AIIE? Those who are in overlap of 2 or overlap of all 3 sections. Overlap of 2 sections means you were there above 80th percentile in at least 2 sections, which was the cutoff condition as such. So anybody who is in the overlap of 2 as well as overlap of 3 would have qualified for AIIE. So that value is 170. Now let's take a look at the last question. If the number of candidates who are at or above the 90th percentile overall and also at or above the 80th percentile in P in CET is more than 100, how many candidates had to sit for a separate test for BIE? So we are saying at or above 80th percentile in P in CET. So let's see in both cases how many people are at or above 80th percentile in P in CET. So we have, in this case, we have that value to be 3 plus 18, that is 21. 21 plus 41 is 62. So 62 plus 42 is 104. So this, in this case, number of people who are at or above P, 80th percentile P is, this is above 100 as such. So this case satisfies the given condition. Let's see what is the case over here. It is 10 plus 10, 20, 20 plus 20, 40, 40 plus 40, 80. So in this case it is 80. So this is less than, this is not, this case is not greater than 100. So this case is not applicable. So in this, in the last question, this particular Venn diagram is applicable. So we have to solve using this Venn diagram. So let's take a look at what the question actually asks. How many students had to sit for a separate test for BIE? Now who has to sit for a separate test for BIE? Those who scored above 80th percentile in P but did not qualify for AIIE. So how many scored above 80th percentile in P? We have been told in the question itself that 400 scored above 80th percentile in P. Now we have to remove all those who qualified for AIIE as such. So let's take a look at the Venn diagram. So we go back. So how many qualified for AIIE? The people who lie in the intersection of P and C, P and M, and overlap of all 3 sections would have qualified for AIIE. So we have to remove these three portions as such. So that is 400 minus the sum of 18, 41 and 42. So this is equal to 83, that is 91, 101. So we get 400 minus 101, so this is equal to 299. So 299 people had to sit for a separate test for BIE. So this is how we answer the question. So as you could see, this was a slightly tougher question on Venn diagrams. Here you were not generally what happens in Venn diagram is after you solve the LR set, you are given one, you end up with one Venn diagram. In this case, you ended up with two Venn diagrams, and depending on the question, different Venn diagram was applicable as such. So always make sure that in this case what you should have done is, once you realize that you can't solve the question, you can't completely fill the set as such from the given conditions, go and see the questions. In the questions you are given things like, if this was a multiple of 5, if this is greater than 100. From this very basic thing you can see that different cases are applicable and you should draw different scenarios. Whenever you see that the question specifically asks for a particular scenario, then you have to understand that, you know what, there are multiple scenarios that are applicable. Draw out those scenarios and then answer the questions. So this is how you solve this particular question. Pretty simple question on Venn diagrams. You should have been able to solve this. This did not require a whole lot of logic as such. It just required perseverance. So this is something that was easily solvable if you guys didn't give up. So now let's take a look at the next question from the slot. So this question is simple happiness index. I felt this question was the hardest of the lot because I felt this was this required a lot of counting, and I'm not always sure of counting in the exam because it's like very tricky. You can make a lot of mistakes during counting, especially when you have the pressure of the exam on. So let's take a look at the question. Simple happiness index of a country is computed on the basis of 3 parameters: social support, freedom of life choices, and corruption perception. Each of these 3 parameters is measured on a scale of 0 to 8, integers only. A country is then categorized based on the total score obtained by summing the scores of all the 3 parameters as shown in the following table. The following diagram depicts the frequency distribution of the scores in S, F and C of 10 countries: Amda, Benga, Kala, Delma, EPA, Varsa, Vona, Zanda, Yanga or Zuma. So it's just A, B, C, D, E, V, W, X, Y, Z, and you have given what the categories are and how the scoring is done. So this information is like basic information. There is no clue as such to be used here, so you can ignore this. Let's go on to the actual information. So here you are given a frequency distribution. So how do you read this graph? So essentially you see all the blues. So you see if S is blue. So 3 countries scored 3 marks out of 8 in S. 3 countries scored 4 marks out of 8 in S. 1 country scored 6, 1 country scored 7. F, 2 countries scored 1, 1 country scored 2, 2 countries scored 3, 1 country scored 4, 3 countries scored 5 and 1 country scored 7. Similarly, C is 1 country scored 1, 3 countries scored 3, 4 countries scored 4, 1 country scored 5, 1 country scored 4, sorry, 1 country scored 1, 3 countries scored 2, 3 countries scored, 4 countries scored 3, 1 country scored 4, 1 country scored 6. So this is how you read the graph. Additional information that is given is Amda and Kala jointly have the lowest score 7 with identical scores in all the 3 parameters. Zuma has a total score of 17. All the 3 countries which are categorized as happy have the highest score in exactly 1 parameter. So this current frequency distribution diagram is not easy. To answer the questions, mostly what would be helpful for you is if you have a table form. So let's first convert this frequency distribution into a table form, so then we can take a look at how to convert that into a usable form later on. So first let's convert this frequency distribution table into a graph into a table. So let's first draw this out. So we have 1, 2, 3, 4, 5, 6, 7. Oh, okay, so that's though the score 8 is 0 to 8, nobody scores 0, nobody scores 8. If you add them all up, you see that all of them are adding up to 10. So there are 10 countries, and if you add all of them up, you get 10 in each of these. So this has 3 plus 3, 6, 6 plus 2, 8, 8, 9, 10. F has 2 plus 1, 3, 3 plus 2, 5, 5, 6, 6 plus 3, 9, plus 1, 10, and 1 plus 3, 4, 4 plus 4, 8, 9 and 10. So only scores are from 1 to 7. So I'll ignore this particular row. Then we have S, F and C. So let's convert the information that is given here. In S, no country has scored 1, so this is 0. No country has scored 2. 3 countries have scored 3. 3 countries have scored 4. 2 countries have scored 5. 1 has scored 6 and 1 has scored 7. In F, 2 have scored 1. 1 has scored 2. 2 have scored 2. 2 have scored 3. 1 has scored 4. 3 have scored 5. This is 0 and this is 1. In C, 1, 3, 4, 1, 0, 1, 0. So these are the values that are given. So now let's go back to what else is given. Amda and Karala jointly have a lowest score of 7 with identical scores in all 3 parameters. Zuma has a total score of 17. All 3 countries which are characterized as happy have the highest score in exactly 1 parameter. So to be happy, you have to have a score, total score of more than between 14 to 19. So only 3 are categorized as happy. So only 3 have a score between 14 to 19 as such. So let's take a look at, so essentially if we consider the questions as such, we have to find out how much each of these, as far as possible we have to figure out how much what each of these countries scored in each of the parameters as such. So we have this frequency distribution. What we need for like answering our questions is like a table where we have the frequency or like the scores of each country as such. So we have A, B, C, D, E, V, W, X, Y and Z, and we have S, F and C. We have been told that this total for, okay, I'll just extend this out. For Zuma, this is 17, this for A and C, our lowest is 7. And there are 3 countries which are over 14, in the range 14 to 19 as such. That's all the information that is given in the previous list. And A and C have identical scores in all 3 parameters. So this is what information that we have. Now, let's take a look at the first 2 questions as such. The first question is what is Amda's score in F and what is Zuma's score in S. So we have to try to find the individual values for Amda and Zuma. So if we consider that A's and C's sum is identical across all 3 columns and the total is 7, we have to find out what is the way that we can show a sum of 7 as such. So 7 you can get in the following ways. So I'll just write it in this corner. So you have 1, if you have 1 is 1 score, the lowest score, then we have to have 2, 1 plus, say 1 plus 1 plus 5, 1 plus 2 plus 4, 1 plus 3 plus 3 and 2 plus, I'm just considering all the combinations that are possible. It need not be the case that you score 1 in S or 1 in F or something like that. I'm just saying that you can score a total of 7 by scoring 1 plus 1 plus 5 or 1 plus 2 plus 4 or 1 plus 3 plus 3. Or you can score 2 plus 3. Now, let's consider after this there is nothing else because 2 plus 2 plus 3 is almost as evenly distributed as you can get. So, these are all the like possible combinations of scores as such. So, let's see which of these are possible. If you have 1 plus 1 plus 5, you need, you need 2 ones. So, you need 2 ones in either S or F and F or C or S or C. Because they are scoring the same figure, 1 in the same column. So, if you have 1 over here, 1 over here, 1 over here, 1 over here, that means there will be 2 over 2 F's and 2 C's. But we see that there is only F has 2 ones. So, we cannot have 1 plus 1 because what I am basically saying is that if you have 1, 1, 5 then and 1, 1, 5, then A and B both have scored ones in S. So this will have to be 2, but this can't be 2. So this can't be 1. Similarly, if it scores 2, this can be accommodated because it has 2 ones. And even this can be accommodated, but this can't be accommodated, so it's not possible. Similarly, if we put it in any way, if we have 2 ones, we'll have to have a 2 over here in the frequency distribution of this table for 2 columns as such, and it's not there. So 115 is impossible. So I'll remove this, I'll just remove the particular fillings also. So 1 plus 1 plus 5 is not possible. Now consider 2 plus 2 plus 3. The same applies. If it's 2 plus 2 plus 3, I need 2 in at least 2 of these 3 values. So at least 2 of these should be 2 or above 2. But we see that it's 0, 1 and 3. So it cannot give me 2 2s. So I can't have 2 plus 2 plus 3 and 2 plus 2 plus 3 because there have to be 2 2s in 2 columns. So this is also not possible. So I'll eliminate even this option. So there are 2 things possible, that is 1 plus 2 plus 4 and 1 plus 3 plus 3. So we have at least there is one that one score is 1. Now in what column can we get these ones? So in this case, if both score 1 on a particular parameter, the frequency distribution has to have 2 over there and only F has 2 over there. So both must score 1 in F. So this can be 4 and 2 and 4 and 2, or it can be 3 and 3. So the 2 possibilities are 4 and 2 or 3 and 3, and the correspondingly this is 2 or 4 and 3 and 3. Same here, 4, 2, 3 or 3. It's A and C. So 2 and 4 and 3 and 3. But in either case, this value has to be 1 because only F can accommodate 2 ones. So that's how the F score for Amda will have to be 1. Now let's see the score for Zuma is 17. So Zuma has anybody who is in the happy index, and there are 3 who are in the happy index, would have scored highest in exactly 1 parameter. So the 3 would have, one would have scored 7 here, one would have scored 7 in F, and one would have scored 6 in C. So essentially Zuma could have scored 7 in S, or it could have scored 7 in F, or it could have scored 6 in C. These are the 3 cases as such. Now if it scored 7 in S, then how much could it have scored in F? It can't score 7 again in F because you can score the highest in only 1 parameter. So the next highest value is 5. So it can have 5, and then next highest value for C is 4. So this value is 4. This way it can score 16. So essentially the highest, if it scores 7 in S, the next the total max sum that it can actually score is plus 5 and plus 4, that is 16. So this case essentially means that it's not possible for Zuma to score 17 if it scores 7 in S. Now let's take a look at if it scored 7 in F. If it scored 7 in F, then it can score 6 in S, plus it can score 4 in C. So that is 10, 17. So this is one possible case, 7 in F, 6 in S and 4 in C. Now consider the third case where it scores 6 in C. If it scores 6 in C, then it can score, these two are out of picture because they are the highest. So it can score 6 in S plus 5 in F. So again this is sums up to 17. So the only 2 possible cases are 7 plus 6 plus 4 and 7 plus 6 plus 6 plus 6 plus 5. So in both cases we see that it scores 6 in S. So the value for S will be 6, and this can be 7 and 4, 7 here and 4 over in C, or this can be 6 and 6 in C and 5 in 5 in F and 6 in C. So these are the 2 options that are available to us. So we have filled the table as far as the information that is given to us. So let's take a look at the first 2 questions. The first question is, what is Amda score in F? So let's see this. Amda score in F is 1. Though we have not filled most of the table, we have filled in the values that are required to answer this question. So we can answer this question. So the answer to this question is 1. What is Zuma score in S? Zuma score in S will have to be 6. As we saw in both cases, it has to score 6. So the answer here is 6. So we could answer the 2 questions pretty easily. Now let's take a look at the third question. Benga and Delma, 2 countries categorized as happy, are tied with the same total score. What is the maximum score they can have? So I've just put the frequency distribution twice. So the reason why I have done that is because we have found 2 cases where values of Zuma score are either 6 in S, 7 in F, and 6 in F, 7 in F, and 4 here, and this is Zuma score. And the second, this is 6 plus 6 plus 5. So these are the 2 scores, possible cases for Zuma. Now in addition to this, we have been given that Benga and Delma are 2 countries categorized as happy and are tied with the same total score. What is the maximum score they can have? Now we see that Zuma scores is 674. So we'll mark those off from the frequency table. In this particular case, if we mark off these values, we get this is 6, so this is gone. This is 7, so this is gone, and this is gone. Now we have to figure out what is the max score Benga and Delma will. So Benga and Delma are the other 2 countries categorized as happy. So one would have scored this value here, and one would have scored this value here. So now it's just asking us what is the maximum score they can have. So we don't care whether Benga scores this or Delma scores this. So let's just say that Benga scores 7 here. It doesn't matter because we just have to figure out what is the maximum score they can have. And they are tied. So we have to have maximum equal score as such. So what's the max score that somebody who scored 7 can have? If you score 7 here, these values are gone. So you get 7. Now the next value, highest value in F for you is 5. So we have 5 here. The next highest value, this is if this is Benga, this is Delma. So this is no longer available to you. So the next value you have is 3. So this is 3 for you. So this value is essentially 15. Now suppose you have scored this 6 over here. What are the next values that are available to you? You have 5 over here and 5 over here. So for you, it is 6 plus 5, that is 16. But one of these guys can score 15. But the guy who scores 7 in S cannot score 16. So if they are tied for values, this guy will also have to score 15, because whoever scores this can at max score 15. So essentially this guy will not score 5 and 5. This guy will score 5 plus 4 or 4 plus 5 in any order. So essentially we get that the max value that these guys can actually score in the this is 15, because the person who scores 7 in S cannot score 16. So if they are tied at the same score, the maximum score they can have is 15. So now let's take this was one case. We have to make sure that for this case this was 15. We have to make sure that this is true for the second case as well. In the second case you have 6, 5 and 6. So let's rub that off. 6. So this becomes 2, and again 6, I rub that off. So now one of Benga has to score 7 here, and one of Delma has to score 7 here. So now consider the person who scored 7 in S. For this person, the next highest score is 5 here, and the next highest score in C is 4. So that is 7 plus 5 plus 4. So that is 16. Now suppose this guy is here. So for him, the next highest score is 5 here, 7 plus 5. But this 4 is already taken by Benga. So this 4 is no longer available. So he has to go to 3 now. So because only one 4 is available, that is 7 plus 5 plus 4, and 7 plus 5 plus 3, that is 15. So if we see that the higher 2 teams cannot have 16 even in this configuration. So the max score that they can be tied for, where both teams Benga and Delma score the same, is 15. So the answer to this question is 15. Now let's take a look at the last question of the set. If Benga scores 15 and Delma scores 15, Benga scores 16 and Delma scores 15, then what is the maximum number of countries with the score of 30? So again, let's do the same this where we have Zumas and configuration out first. So Zuma is 674 or Zuma is 656. And we have, let's just rub that off. So we have 6, 7 and 4 gone, and we have 6, 5 and 6 gone. So we have to figure out if Benga scores 16 and Delma scores 15, then what is the number of teams, countries with a score of 30, maximum number of countries with a score of 30. So let's consider this case, the first case, case 1. So in case 1, Benga scores 16. So how can it do that? If it scores 7 over here, it has to score 5 and Delma will score 6. So if it has, so this is 7 plus 5 plus, it has to go down to 3. There is nothing else in C as such available to it. This is by Delma. So in that case, it has to score 7 plus 5 plus 3. So that is 15. So Delma would have scored 7 plus 5 plus 3, that is 15. And Benga would be over here, that is 6. So this would be Delma. This is Benga. So Benga would have been over here. So this is 6 plus 5 plus 5. So this is actually, this is S, this is, what do we have here? This is F5 is in F and this is C, and 6 is in C, 5 is in S and F. So let's rub those values out. So we have already put, this is gone, 5 is gone, so this is 2 now, and 3 is gone, so this is 3, and this is 6 plus 5 plus 5, so this is gone. And 1, this is gone, and 1 is left. So we have essentially 1 5 in S, 1 5 in F, and the highest available value in C is 3. So if we see the max values that are available to us, max values available in S is 5, max value available in F is 5, max value available in C is 3, and only one of S and F are available. So only one team can score 5 over here, 5 over here, and there are 3 available here, but only 1 is necessary. So only one team can score 5 plus 5 plus 3, that is 13. So the max sum available to us now is 13, and only one team can score this. So a maximum of one country can have a score of 13. So according to case 1 answer is one country. Now let's take a look at case 2, which is this diagram. So in case 2, let's rub out what we have put here. So we already rubbed out this. So Benga scored 16, Delma scored 15. So if we have, as I said, we have already rubbed this out. So this is 7, then we have 5, and then we have 1 over here, 4 over here. So that is 7 plus 5 plus, so we have, say Benga would in this case would be 7 in S plus 5 in F plus 4 in C. It doesn't matter whether it is 7 in F or this, because the opposite is also possible, where Benga scores 7 in F and then 5 in S. It doesn't really matter, because the only thing that matters is whether it takes 4 or it takes 3. So this is one possible configuration. We just have to, or it can be the inverse also, where it scores 7 in F, 5 in S and 4 in C. Delma, as this is now gone, will then score, and this is also gone, this is also gone. Delma will score 7 in F plus 5 in S plus, since 4 is gone, it will score 3 in C. So this is 15. This can be again F and S alternately. So, but we will just first mark off these values. 7, 5, I marked off 7. I didn't mark off 5 yet, so I'll mark off 5. So I have removed 1 5 from F, and I'll remove 1 5 from, I've removed 1 5 from S, I'll remove 1 5 from F, and the 4 C is gone, and 1 3 C is gone. So this is 3. So I've marked off everything for Benga and Delma also. So again in this case we see we are left with the max score that we can get is 5 plus 5 plus 3, that is 13, and only one team can actually, only one is left over here. So only one country can score 5 plus 5 plus 3. So in this case also the answer is 1. So in both cases the answer is 1. So the answer is the maximum number of countries that can score 13 is 1. So this is how we solve the set. As you could see that we needed to extensively use the frequency table. So you would have had to like make multiple changes to the same table over and over again to actually do this well. This was a time intensive set. There's no denying that. I would have suggested that if you could make a broad enough table where you can draw the conditions and quickly mark off different cases in the cell within itself, you would have saved some time. But generally I feel that in these kind of cases, this set is on the harder side. While picking the set, I would not ideally pick this set because I don't think this is a good set to pick. This set you should pick once you are already done with 4 sets and you don't have time to solve an entire new set. You could have, if you saw, you could have solved the first 2 questions easily without doing any of these harder calculations. By just simple logic, you could have solved the first 2 questions. So what you would have gotten is, you would have gotten 4 plus half of a new set. So you could have done that easily if you have just like 4 or 5 minutes left in your DILR section. You don't have time to attempt an entire new set. Then this set would have made a lot of sense. You could have gotten the first 2 questions right without any major effort as such. So this is how you solve questions in DILR. We have done sets, in slot 1 we have done 1, 2, 3 and 4 so far. So in the next video we will be taking a look at the 5th and 6th DILR set from slot 1. So please subscribe to our channel to see more videos of this type. Click the bell icon to subscribe to this channel, and please check the description box because we have put in a lot of free stuff there. We have put in free mock tests, more links to videos like this. So please do check out our description box and please subscribe to this channel. Thank you.